This is the instructional video for lesson 2.3. In this lesson we are going to add, subtract, and multiply polynomials. So the objectives, as you can see here, I can add and subtract polynomials both vertically and horizontally. Horizontally means that we're going to leave the two polynomials next to each other. Vertically means that we are going to stack the polynomials on top of each other. So for the second objective, I can multiply polynomials horizontally. So we're going to take a look at adding some polynomials, and then we're also going to subtract. So to add or subtract polynomials, only add or subtract the coefficients of like terms. Recall that for terms to be alike, they need to share the exact same variables and the same degree. So we want to look for things that are alike with the same letter, okay, and the same degree or exponent. All right, so for problem A, we're just going to leave these as they are next to each other. So we're going to do this in the horizontal format. So I first have to look for things that are alike. I have an x to the third here, and I have an x to the third here. It's understood that there's a 1 in front of this x to the third. So I can add together this 1 plus these 2, and I end up with 3x to the third. All right, and then we can look for things that are alike that have an x squared. This one is an x squared. This is an x squared. I have a positive 6, and I have a negative 5. Therefore, I just have 1 left, right? So 6 minus 5 is 1. And then it looks to me like we do not have anything to match up with the 3x over in our other polynomials. So we'll just say that that's going to be 3x. And then finally we have the negative 9 and the positive 11, which is just positive 2. And we left this in terms of lower degree exponents. You know, as we go, we should have the highest one first, then the next lowest, then the next lowest, and then our constant term. So we want to make sure that it is in standard form when we finish our work. All right, let's go ahead and stack. Vertical means that we're stacking the two polynomials, and what we need to be careful of is to watch for the degree and make sure that we line that up with the degree in the first polynomial. So there was no y to the third in this polynomial, and so I can just go ahead and write in here negative 4y squared. Notice that I'm lining it up with the negative 2y squared plus 2y, and then minus 5 is going to go over here. So in this polynomial on the top, we don't have a constant, and in this polynomial down here, we did not have y to the third term. So now I can just draw my line, and I can just add just like we would normally add anything else. So I have 3y cubed minus 6y squared, right? Negative 2 and negative 4 is negative 6, and then negative 7 plus 2y is going to be negative 5y minus 5. All right, and there's our final answer. So adding and subtracting, well, sorry, adding is not super difficult. You just do have to remember that you can only add things that have like terms. So x cubed here, x cubed here. Those are the things we matched up. I tried to color code things a little bit for you as I was working in this problem. Stacking or using a vertical format, want to make sure that we line up things that need to be lined up. Okay, things that are alike need to go underneath each other. And if we take a look at example 2, we're going to be subtracting polynomials. Subtracting polynomials gets a little bit tricky because we have to look and see what they want us to do specifically. It says to take this polynomial and subtract it from this polynomial. So we have to subtract 3x cubed plus 2x squared minus x plus 7. All right, and it is hard to write those right underneath them on my iPad here, but you can kind of see that this is being, you know, I'm sectioning the things that I can section and lining up those terms underneath what they should be lined up with. So if I need to subtract something, I have to make sure that I change the sign for every single term. So I'm going to rewrite this whole thing just so that it's a little bit more clear. So 8x cubed minus x squared minus 5x plus 1 is our first polynomial. And now when I apply this negative sign, I have to distribute it to every single term. So what's important is that you change the sign in front of every term on this polynomial, okay? So because it's positive here, I need to say negative x cubed. And because this is positive, I need to say negative 2x squared. And because this one is negative, I have to change that sign to a positive. And then this sign here for the positive 7 is going to be negative 7. So we're distributing the negative to every single term. And again, you want to make sure that it's all lined up. So I have my x cubed first, then my x squared, then my x's, and then my constant terms. All right, so 8x cubed minus 3x cubed is going to be 5x cubed. And then I have a negative 1 and a negative 2. This should be an x squared, I think. So negative 3x squared. And then a negative 5 and a positive x, so that's going to be negative 4. And then we finally have negative 7 and 1, which is just negative 6. So this should be our final answer. And we'll do another problem here so that we can see how this works. If we look at this problem, it says to take this polynomial from this polynomial. Well, this one has 3 terms. This one only has 2 terms, so I'm going to have to be careful about what I subtract or what I, what things I combine. And remember that we're taking this one from the other one. So it's going to be 4z squared minus 9z minus 5z squared plus z minus 3. Now notice what I did. I took the negative sign and I made it positive. And I took the positive sign and I made it negative. And then there was the 5 here, the leading coefficient was positive, so I made it negative. All right, so I'm still leaving it in this horizontal format. I did not stack the 2 polynomials together in this problem. And so that's going to be our horizontal format. So I'm going to find things that are alike. This 4z squared is like this negative 5z squared, and I'm going to combine those. That's going to be negative z squared. Then I'm going to have negative 9z and positive z. That's negative 8z. And then I have a negative 3 over here. Okay, so this gets a little bit more complicated when we're subtracting the polynomials because we want to be careful. Distribute the negative, and you want to make sure you know what you're subtracting from what. And that's going to be a little bit challenging. You'll just have to be a little bit more aware of what you're doing. Okay, we are on the back of our note sheet and we are looking at example 3. It says find the sum or difference of the polynomials, and I would like you to do these on your own. And so this negative sign, remember, has to be distributed to each one of these, and I'm not going to be picky about whether you use the horizontal or vertical method. Whichever one seems easiest to you is the one you should use. All right, and now we are going to learn about multiplying polynomials. To multiply polynomials, we must multiply each term of the first polynomial by each term of the second polynomial, and then recall that you're going to have to add the exponents when multiplying the same variables together. And it's often necessary to combine like terms after multiplying polynomials. So if you remember in our previous semester, we would have things like this that we would have to FOIL. And these are just 2 binomials. So let's just say we have this, and we would do the first terms, then we would do the outside terms, and then the inside, and then the last. It's going to be kind of like that, but we have to make sure that we multiply every single thing in the first binomial or polynomial by everything in the next one. So this one has 3 terms. This one only has 2 terms. So it's going to be a little bit more than we had when we were doing just 2 binomials together. So I'll write this out a little bit differently than I did in the foiling. X plus 3 is going to have to be multiplied by 3x squared. And we have to multiply x plus 3 times negative 2x, and we have to multiply x plus 3 times 4. Okay, so I took each one of these terms in our polynomial and made it an outside or something that we would have to distribute to both terms inside the binomial. So if I do that, I'm going to multiply 3x squared times x, and I'm going to multiply 3x squared times 3. So that's going to be 3x cubed. Remember, this has a little 1 right here, so I'm adding the exponents, plus 9x squared. All right, so I've done that one. And now I have to distribute the negative 2x to this x and to this 3. So that's going to be negative 2x cubed. Remember, there's the little 1 here, minus 6x, plus, I'm going to have to distribute the 4x plus 12. And my next step is going to be combining like terms. So I have a 3x cubed and a negative 2x cubed, and so I end up with just x cubed. And then it looks like I have 9x squared. There's no other x squared terms, so that's just going to be 9x squared. So I've already taken care of this one, this one, this one. Now I have to combine the negative 6x and positive 4x, which is negative 2x, and then finally we have our plus 12. Okay, so you just want to make sure that you combine everything, don't leave anything out. That's why I did this crossing off method and, worked kind of with some symbols there, but this should be our final answer. So again, when you're multiplying polynomials, make sure that you take each piece and you multiply it by everything in the other polynomial. And I'm going to try this other one with you, problem B. So we have x minus 5, which is a binomial, and x plus 1, which is a binomial, and then we have x plus 3, another binomial. So they all have to be multiplied together. So if I do my FOIL method and I do the first outside inside last, I'm going to end up with, if I'm multiplying these two first, x squared plus x minus 5x minus 5. If I'm just multiplying these two together, remember the first, then the outside would be the plus x, the inside would be the negative 5x, and then the last one would be the negative 5. Now I have to multiply everything by x plus 3 because there's this other polynomial here that still needs to be multiplied. Before I do that, I'm going to combine these two so that I can condense this down a little bit. So x squared plus, I guess I should make that a negative. Let's do this again. X squared minus 4x minus 5. And I'm going to multiply that by x plus 3. Okay, so if I rewrite this, I'm going to have x plus 3 times x squared. Remember, we have to do every single term, plus x plus 3 times negative 4x. That's this term here, plus x plus 3 times negative 5. So I'm going to run out of space here, but the idea is that you're going to multiply every single thing by the number that's outside, or by the variable that's outside. Okay, and I'm just going to write the answer. I'm going to stop my recording, calculate my answer, and then I'll write the final answer on here. But you'll see the same kind of work was done right here in the previous problem. Okay, so here's our final answer after all the numbers were crunched. The final answer for problem B is x cubed minus x squared minus 17x minus 15. And I'll leave more space on your assignment sheets so that you don't run out of room here. All right, let's take a look at one more problem, and these again are just products. Product does mean multiply, if you've forgotten that. So I think that I'm going to have you do problem A. That's going to be just a FOIL problem. And then I'd also like you to do problem B. And then I would like to point out here that this cubed means that we're doing 2x minus 3 times another 2x minus 3 times another 2x minus 3. Okay, so that's just 3 times we have to multiply that out. So I will start with these two, foiling those, and then each one of the things that we get when we FOIL, we have to multiply again by 2x minus 3. So in class, we will use some lined paper. There's not enough room on this paper. You'll just have to attach the lined paper to your note sheet. All right, and I think as we move forward and practice more and more of these, they will definitely become easy because you guys are good at adding and subtracting things. It's just, remembering the fine points and not missing any of those little details. All right, we'll take some questions in class.